Hi everyone, I hope you are doing good. So today in this video we will take a new DSA question, and that is k sum paths. So and the question is there will be a binary tree, right, and an integer k. So one binary tree will be given. So this is not binary search tree, so you have to keep in mind this is only binary tree, right, and a k. Determine the number of downward only paths where the sum of the node values in the path equals to k. A path can start and end at any node within the tree but must always move downwards, right? So it is saying one binary tree will be given, one k value will be given, so you have to find the paths, number of paths, which if we add all the nodes in that path, then that makes the sum equals to k, right? So for example, let's understand with the given examples here. So the first use case given is here, right? This is the binary tree, right? And here you notice this is 4 and this is 5, and both are the less than the parent node, correct? So this is not a binary search tree. In last video I have explained about binary search tree and binary tree differences, right? And how can we determine some given tree is a binary search tree or not. So let's focus on this problem here. So this is binary tree and here k is 7. So we have to find all the paths which makes a sum to 7, right? So if we notice here, then one path is this one, 4 and 3, right? This is one path is this one, 4 and 3. One is this one, right? 4, 2 and 1. This is also making 7, and one is this one. So these three paths which makes sum to 7. So here this is the binary tree, and here k is 3. So we have to find all the paths which makes 3, right, sum. So here 1 and 2, that is 3. So 1 is this one, this could be the result 1, and the other one is also this node also standalone makes the sum up to 3, right, equals to 3. So here output would be 2. So this is understandable, right? I hope you are getting it. Now think about the solutions. How can we implement our algorithm so that we can get the expected output, whatever we have discussed, right? So think about that and let me know if you have any other solution than whatever I will tell you. So and comment below the video so that we also get to know what you are thinking. So what I am thinking is making use of map in our solution, and so this is the code I have added for this problem, and let me explain you this. So what I will do, I will create one map here, basically unordered map, right? Because I don't care about ordering, right? That is why I have used unordered map, right? And then I have initialized the initial value is 1 here, right? So I have created map, so you can say this one, right? Correct. Now the initial value, 0th value key, this is key, and this is value, this is 1, correct? And then what I will do, I will pass this map, this k, and this is root, and I have added a helper function here, solve, and it will take the node, the root value, right, this one tree, and then k, whatever the given k, right, and then unordered map as a reference, and then sum, right? This sum will be the sum of the node values basically, right? So here if node is null, then we will return, else we will go down and we will add the sum, the node value to the sum, right? So here you can say sum also, right? So initially the first node, when we encounter the first node here, this one, this is not null, so it will go down, correct, and we will add this value to sum, so sum would be 8 here, correct, and then we will find 8 minus k, sum minus k is there in the map or not, right? We are checking u map dot find sum minus k, right? So this sum minus sum is 8, k is 7, correct? So 8 minus 7, that is 1 is not there in the map, right? It means the sum of the nodes is not making 7 basically, right? If it is making 0, like if the value is 7 here, in that case it would be making 0, the k sum, but it is not, right? We are getting sum that is 8 minus 7, that is 1, right? 1 is not there in the map entry, correct? So we will skip this and we will go here and u map sum plus plus. So what it will do, basically it will add one entry in the map with this sum, and if we do plus plus, then it will make the value to 1, right? So here sum is 8, so you can say 8, key would be 8, and value would be 1 here, correct? And then we will go here and then we go for left node, right? So now we are here on this, and this is not null, so here again we will go and sum is equals to sum plus node arrow data, that is 4, 8 plus 4, that is 12. Now sum is 12, correct? And then 12 minus 7, we are checking here sum minus k, so 12 minus 7, that is 5. 5 is not there in the map, so we will not go inside this if block, and then again we will add the entry of the sum here, new sum, that is 12, right? So 12, then 1, correct? And then again we will go for the left here, and now we will add this value because this is not null, right? So we will add this sum here, this one, sum is equals to sum plus node arrow data, correct? So 12 plus 3, that is 15, 15 minus 7, that is 8, right? Here this one is, right, umap dot find 15 minus 7, that is 8, and we see this entry is there already. What does it mean? It means like 15 minus 7, then we are making this these two nodes, and the sum of these two nodes is 7, correct? Why? Because the total sum is 15, and out of 15 we are just subtracting 7, and then it is making 8, and 8 we have one node, or you can say the sum till this node basically, and after this we are making 7, right? So if this is found, now the node entry is already there, it means after 8 we have added nodes which are making sum to 7 equals to 7, right? So what we will do, we will total is 0 initially, 0 plus u map like the value of this one, right, that is 1, right? 0 plus 1, right? And this is mode of this value, right? So it would be this one, so total would be 1 here basically, right? So I hope you are getting this one. So here the total here, let me add here, total would be 1 because this is 1, and now add this entry here, again we are adding this entry for 15 sum, right? So this is 15 and this is 1, correct? And then after this we will go down here, line number 108, and we will go for left again here. If we come here, then for left 3, then again after 15 we will add to 3, that would be 18, right? Sum would be 18, and 18 minus 7, that is 11. 11 is not there in the map, correct? So it means including this one, this node, we are not making sum to 0 basically, right? With any number of nodes here. So now we will add this entry here, 18 and 1, correct, from here, and then we will go left here, left is null, so we will come back here, and then we will go right of this node, root right, and this is also come back here because this is also right, is also null, and then we here come here, line number 112, right? And here you see u map sum minus minus, we are removing that entry, last sum entry, whatever we have added we have to remove, otherwise it will basically add the false values, which will increase the number of totals, right? That is why. So or you can say it will be recounted basically if we do not decrease this one. So that is why what we will do, whatever we have added 18, right, sum is 18, so we will decrease this one to 0, right? And here you can add also one more line here, like u map if this u map of sum is 0. If it is 0, in that case what you can do, u map dot erase and sum, you can do. So why? Because now 18 and 0, so this does not make any difference in the in the result. That is why you can delete also it. That is up to you, right? So this is the thing. Now coming going ahead, now we are here, right? And then what we will do, we will come back again from here, right? So we will come back here in the upper node. Let me clear this one. So we are coming back here, and then we will go right side here, correct? So right side, so here what would be the sum? Here sum is basically 15, right? 15. So now 15 plus minus 2, that is 13, right? Sum is 13 now. 13 minus 7, that is 6. 6 is entry is not there, so we will not go inside this one, and here we will add the entry 13, right? So here just add the 13 entry, 13 and then 1, correct? And then after this we will go right left side, we will come back, and then we will go left, then we will come back, then we will go right, right, and then we will come back. And after this coming back, we will basically remove this 13 entry, last entry, right? Because it is not making any difference in the result, correct? So we will remove this one here, and then we will come back here. And after this, what we will do, we are here now, right? And then again in this node we have traversed left and right both, so we will again go up, right? One step one node up here, and we will remove this entry also, this sum entry also. It means we will remove this 15 also, right? 15 and 1, correct? So or you can say we will make this to 0, this 15, we are doing minus minus, right? Basically, so it is 0 now. And we are here now at fourth node, this one, second node, correct? And we will go right using this line, right? Right, and right is 2. So now it will make here the sum is 12, correct? 8 and 4, 12, 12, this one, 12 plus 2, that is 14. So it will make 14 here, sum is 14, correct? 14, 14 minus 7, that is 7. 7 entry is not there in the map, so we will not do anything in the result, in the total. And we will add this entry also, right? 14, 1, correct? And then again we will go for left of this, left of for this one, left of this node, right? Left of this is nothing, so it will come back and it will go for right, and right we have 1, so it will go here, it is not null, it will come down here, and it will add this entry 1, right? So 1, 14 plus 1, that is 15. So this is 15 now. 15 minus 7, so we are here, correct? So 15 minus 7 is 8, and 8 is already there, so it will add 1, correct? So there are only one way to make 8 here, right? So what we will do in total, total plus u map of sum minus k, that is 8, it will give 1 value, right? 1 plus 1, this one, so total would be 2 now. So now it would be 2, correct? Because 1 we got this one, right? And 1 we got this one. 4, 2 and 1. So these two ways where we are making 7, correct? Now coming back from here, so what we will do, we will remove this 14, 1, sorry, 15, 1, right? So we have added this 15, 1 here, correct? So now we are so we will add, and then what we will do, we will go for left here, so we will come back, then we will go for right, and we will come back, and from here also we will come back. And once we are, while we are coming back, we have to remove the last sum also, or we basically decrease this one. So we will make this to 0, 15, correct? And then from here also we are coming back, because left and right both traversed, so we will come back here, and 2, so this is 14, 14 also we will make 0, correct? And then from here also we have for fourth node, this one, right? We have also traversed left and right, so we will come back to root node here, and the sum for this one, that is 12, so we will also decrease that value, that is 0, this one, correct? And now here we will go for right, right here. So right node is 5, So we will come back here, right. So sum is 8 now, or sum is 8 for this node, correct. So 5, we will add this 5, so it would be 13, correct. 13 minus 7, that is 6. 6 is not there in the list, in the map, correct. So we will add one more entry here, or the entry is already there, so let me edit this one. 13 1, correct. We have added this one, and then we will go left. Left is nothing, so we will come back and we will go right here, right. So 13 plus 2, that is 15, correct. So 15 entries there, so just increase the number here, so it would be 1 here. And then 15 minus 7, that is 8, it is already there, so just add one more entry here. Total is 2, 2 plus 1, that is 3. I hope you are getting it, right. And now after this, what we will do, we will come back here and we will decrease basically this 15 1, so it would become 0, and then from here we will come here, and this 5 also we will remove, so this 13 is also removed, correct. And from 8 then we will return to the main function, then this 8 is also removed, correct. So all will be the value for all nodes would be 0 sum, except the 0th one, correct. So I hope you are getting this one. This is little bit tricky, but not a rocket science, you can understand it easily. So what you have to keep in mind, first thing is you have to take one on basically map, a noded map you can take, right. Initially you have to add one entry with key is 0 and value is 1, correct. So for example, this is useful in case we have one node that is 7, initial node is 7, right. And so this 7, so what we will do here, if we check here this line, right, line number 103 here, this one, 7 minus 7, that is 0. So in that case, that one entry will be added. This is the one way we can make the sum to 7, correct. So here, that is why we add this one. I hope you are getting it. So this is the first thing you have to take, one map you have to take. Second, you have to add one entry with key is 0 and value is 1, right. And then you have to pass this to this helper function, right, with sum is 0. And here, if node is not 0, then just add that node value to sum. That is the third thing you have to do, right. And after this, once you have added, then you have to just subtract the k value from sum and then look into the map. Is there any way to make whatever the remaining value subtracted, like the value after subtracting, right. So this is the fourth thing. And fifth one is you have to add that entry, some entry into the map, right. And then you have to, the sixth is you have to check left and right for the same. And the 7th is while coming back, you have to basically either you can remove that entry from the map if it is the value 0, or you can subtract if it is not 0. So that's all for today. See you next time. Till then, keep learning and keep exploring. Thank you.